So today we're going to cover Chapter 11, Section 3. Today we're going to talk about geometric sequence. So a sequence is geometric when the ratio of consecutive numbers are the same. So the sequence A sub 1, A sub 2, 3, 4, and so on is geometric when there's a number R, and this is an R right here, such that when I divide, so when I'm going to take, or the ratios, I'm going to take, for example, the second term divided by the first term will give me the common ratio, or I could choose any. Again, you have to take the term that's to the right of the term you're dividing. So 4 divided by 3 would give you the common ratio, or 3 divided by 2. Just take the term to the right, divide it by the term on the left, and that will give you your common ratio. We're going to be using an R in this formula instead of a D. So here's the formula we're going to be using today. This is going to, if it asks you to find the nth term of a geometric sequence, the A sub 1, again, remember this is your first term. The R, we just learned about. This R is the common ratio, or what you're multiplying by to complete the sequence. So it's always going to be multiplying by the same number to complete the pattern, or to complete the sequence. If it looks like it's dividing, then what we're going to be multiplying by is a fraction. So if it looks like divide by 2, it's really multiply by a half. So it's always the common ratio would be what you would be multiplying by. So let's go ahead and see if we can find the common ratio given a sequence. So here it wants us to find the common ratio. What are we multiplying by to complete our sequence? Again, you can take any two terms that are consecutive. So for example, I could take 2 and divide it by 1, and that would give me 2, which is my common ratio. I could have also divided 4 by 2, 8 by 4, the two that are consecutive, or even 16 by 8. They will all give me 2, which is my common ratio, or my R value. Everybody good so far? All right. The next one, it's asking us to find A sub n and the 10th term. So the formula that we need to fill in, remember, is A sub n, the first term, A sub 1, times the common ratio raised to the n minus 1 power. Now, notice in this formula, I need to find the R. So first thing I'm going to do is find my common ratio by dividing two consecutive terms. So my common ratio I can find by just using the first two. 4 over 12. I'm sorry, the other way around. I'm doing the, sorry, let me see if this will erase. 12 divided by 4. And my common ratio is going to be 3. Now, when you're doing the homework tonight, the questions that I could select from the beginning parts of the homework, and I didn't give you any of these questions. All of the questions that you're going to get tonight, where it's going to first ask you, is this sequence geometric? Every question I have selected for you is geometric, so you will be able to find the common ratio. There were some questions that I could choose from when I built your assignment where they weren't geometric because you weren't multiplying by the same number every time, but every question in the homework for 11.3, they are all geometric, so you can find a common ratio. All right, so now I found the R value. My first term, or the A sub 1, remember this is going to be this 4 that's right here. So my A sub 1 equals 4. And these are the two numbers that I need to plug into the formula to get my A sub n. So it's going to be A sub n equals 4 times the common ratio raised to the n minus 1 power. Now, do not multiply the 4 and the 3. You will leave it just like this. Because remember, we need to follow PEMDAS. So if I multiply that, that's not following order of operations. I would have needed to evaluate the exponent first, get that answer, and then go back and multiply it by 4. So when it asks you to find a sub n, you leave it like that. Do not multiply that first term times the common ratio. Everybody good? Next, it wants the 10th term. So now that I have the formula, I'm going to replace n with 10 and then follow order of operations. So I'm going to be doing a sub 10 to get the 10th term. 4 times 3 raised to the 10 minus 1 power. 4 times 3 to the 9th power. 3 to the 9th power is going to give me 19,683. I can now go back now and multiply that by 4, and the 10th term in my sequence is going to be 78,732. When these sequences are geometric, they're going to grow really rapidly, and they could also get really small really quickly because we're multiplying here. Everyone good on example 2? Now, number 3 has a typo. We need to change one of the signs. So on this one, this third term that's listed here, change this to a plus sign. I'll make that a plus sign. Okay, so it wants me to find the common ratio and my a sub n. So again, let's find the common ratio by dividing. So I'm going to divide -4 by 12, and I'm going to reduce that to -1/3. That is my common ratio. The formula that I'm going to fill in the first term and the common ratio. So for my formula, I need the first term, which is going to be 12. So I'm filling in a sub n equals a sub 1 times r to the n minus 1. So I'm going to leave the a sub n. I'm going to replace a sub 1 with 12. I'm going to replace r with -1/3. And I'm going to raise that to the n minus 1 power. And you're done. So this question had 2 parts. It wanted r and a sub n. I'm going to take it one step further. I know it didn't ask for it, but I'm going to also find the 10th term just like I did in example 10. I mean, example 2, sorry. So let's go ahead and let's find the 10th term using now this formula that we just set up. So a sub 10 is equal to 12 times -1/3 raised to the 10 minus 1 power. 12 times 3, let's see, let me just do this first. -1/3 to the 9th power. -1/3 to the 9th power becomes -1 over 19,683. You're going to write your answer as a simplified fraction. So I could simplify the 12 and the 19,683. I can divide them both by 3. This becomes a 4. This becomes a 6,561. Now I'll multiply what remains, and my 10th term is -4 over 6,561. So don't make it a decimal, leave it as a fraction. Yes?
Are we going to get questions this big on the test?
Probably.
Can you use a calculator or no?
We'll probably give you a basic one. I'll double check with the other teachers, but more than likely a basic calculator. I know the basics don't do exponents though, so I'll double check on that. All right, everybody good? Let's try the next one. Now this time, they're not giving me the whole sequence. They're giving me only the third term and the sixth term in my sequence. They want me to go back and find the first term and the common ratio. Now we did this with the arithmetic or the arithmetic sequences. Remember, in addition to taking into consideration the numbers in the sequence, we also have to take into consideration their place in the pattern. So I'm going to go ahead. Before, when it was the arithmetic or the arithmetic sequence, we sort of did it like a slope. Now, because this is geometric, we're going to treat the difference as a root. So I'm going to do a to the 6, or a sub 6 minus a sub 3, and I get a sub 3. I'm going to be finding the cubed root of what I get. So whatever the difference is, that's going to be the root you're going to take in order to get the common ratio. I'm now going to divide 160 by 20. So I'm going to be doing the cubed root of 8, and my common ratio is going to be 2. So I cube root these. Cube root of 8 is 2. So I found the R. That was the first thing it asked for.
Ms. Gordon, did you get R because you had A3?
Say that again?
Did you get R cubed because you got A3 before that previous step?
Correct. Yes.
Okay.
Let me see. She said Ellen's in the waiting room. Let me look. Oh, thank you for that in the chat. Okay. All right, let's keep going here now. Now we want to find the first term. Now, since this is really close to the beginning, the term that they gave me, if you think about it, we have a sub 1, then a sub 2, a sub 3, and then the next one they gave me was a sub 6. So that's 160. This was 20. But the question asked me to find this one. Now, if I already know the common ratio, and the common ratio normally, to get the next number in the sequence, I'd be multiplying by 2. If I want to go backwards, I could divide by 2. This would be 10. Divide that by 2. And my first term is going to be 5. However, on the test, it's not going to be this close to the beginning. So we're going to need to use the formula. So just to show you that if it was close, say it was an SAT and it was a non-calculator question, you could just, reverse the pattern. So instead, though, what we're going to do is we're going to take our formula, a sub n equals a sub 1 times the common ratio raised to the n minus 1 power. My goal here is to solve for the first term, the a sub 1. I'm going to fill in the given information. I'm going to use this term and plug it in as well as the common ratio. And then I can solve for a sub 1. So I'm going to plug in a sub 3. You could have also used the a sub 6. It doesn't matter. And then I don't know this. My common ratio is 2. And then since I'm using the one that's in the third spot, that's my n value. I'm going to replace a sub 3 with what it equals, which is 20. I'm going to evaluate 2 minus 1, and that gives me 2 squared. And 2 squared is 4. And now I can divide both sides by 4. And my first term of my sequence is 5. So this is what you're going to have to do on the test, because it's not going to be as close as this one. Now, if they wanted, now this one only originally had asked for the first term in the common ratio. Let's say they said to write the equation for a sub n. So then you would just fill in your first term times your common ratio raised to the n minus 1. So if it asked you to find a sub n, that's what you would give. Again, this was the first term and your common ratio. Oops, hit the wrong button, sorry. Okay. Everybody good? Let's try the fifth example. Anybody still need this one? All right, this one also wants the common ratio and the first term. So again, I'm going to do the same thing. I'm going to subtract the places of the terms. So I'm going to be doing a sub 9, a sub 4, a sub 5. So I'm going to be using the fifth root to find the answer here. I also have to divide these. So negative 1 over 128 divided by negative 1/4. I'm going to do a keep flip change here. Negative 1 over 128 times negative 4 over 1. This will simplify and it becomes positive 1 over 32. So r to the fifth equals 1 over 32. In order to find the common ratio, I need to find the fifth root of 1 over 32, which is going to be 1/2. So my common ratio is 1/2. Next, it wants me to find the first term. So again, yes, you could go ahead and reverse. Instead of multiplying by 1/2, you could divide by 1/2 3 times to get it down to the first term. But I'm going to use the formula. So a sub n is equal to a sub 1 times r to the n minus 1. I'm going to use one of the terms they gave me. I'm going to use a sub 4. So I'll plug that here, which is negative 1/4. I'm solving for a sub 1. That's what I'm trying to find. I just found my common ratio to be 1/2. And again, my n value is 4. 4 minus 1 is 3. I now need to evaluate that exponent. 1/2 to the third power is 1/8. I now need to divide both sides by 1/8. And whenever I see a fraction next to a variable, I think reciprocal. So I'm going to multiply both sides by the reciprocal, which is 8 over 1. Because then this simplifies to a 1. And then I'm just left with a sub 1. And then this will also simplify. And I'm left with negative 2. So my first term is negative 2. And my common ratio was 1/2. Next, we're going to find how to find the sum of a finite geometric sequence. Now, if the sequence is short, like maybe only 5 terms, technically you could find those 5 terms and then go back and add them. And that's what we did way back at the beginning. But again, there's a formula that we can memorize. And that formula, and this is for a finite geometric sequence, one that ends, is S sub n, and this is the sigma notation, is equal to a sub 1 times 1 minus r to the n divided by 1 minus r. So if you only want to work with the equation, you could eliminate this, and you could go right to this. Now, you could take this first term, this a sub 1, and just put it all straight in the numerator, if you'd rather, and then divide it by 1 minus r. So you could take this and turn it into that. Now, you're going to be presented some of the questions with the summation notation. So you're going to need to know the different parts of it. And we'll see that as we go through it. Everybody good? So let's try some examples. So it wants me to find the sum of the first 5 terms. Now, let's find the common ratio. Remember, to find the common ratio, we divide. So I'm going to divide 16 by 4, and my common ratio is 4. Now, because this only wants to find the sum of the first 5 terms, technically I could take 256, multiply it by 4, and the 5th term is going to be 1024. Technically, I could go back and add 4 plus 16 plus 64 plus 256 plus 1024, and that's going to give me 1364, which is going to be the sum. But I'm going to show you how to work with the formula, because obviously on the test, it's not going to be this easy of a question where it's going to ask you to find the sum of the first 5. It might want you to find the sum of the first 100. Where you're not going to be able to go back, figure out those 100 terms, and then add them. So let's use our formula. So again, our formula we're using is going to be S sub n is equal to a sub 1 times 1 minus r to the n divided by 1 minus r. So it was important that we identified the common ratio. Now, notice in this problem, my first term, my a sub 1, is also 4. So when I go to plug this into the formula, let me just go ahead and color code it. So my first term, I'm going to put in blue so you know which 4 I'm talking about. And then my common ratio, I'll put it into the formula in red. So the n value is however many terms you are adding up. So here my n value is going to be 5. So let me go ahead and put in all these numbers. So I'm going to be doing S sub 5 is equal to 4 times 1 minus 4 to the 5th power divided by 1 minus 4. You need to follow order of operations here. So 4 and then 1 minus 4 to the 5th power is 1024. 1 minus 4 is negative 3. I can go ahead and subtract 1 minus 1024, and I get 4 times negative 1023 divided by negative 3. I'll multiply the numerator, and then now I'll divide by negative 3. And the sum of the first 5 terms, 1,364. Notice it's the same sum that I got when I added them individually. So again, just to show you how the formula works. Let's try the next example. This time my common ratio and my first term are not the same number, so it makes it, you can see where the numbers go a little bit easier. All right, so again, in order to use this formula up here, I need to know what the first term is and the common ratio. So for number 7, my a sub 1 is 12. My common ratio I can find by dividing. Now again, pick any 2 that you want. So I'm just going to pick the first 2. So negative 4 divided by 12. My common ratio is 1/3. My n value is going to be 5 because it wants me to find the sum of the first 5. So let's go ahead and plug it into the formula. So S sub 5 is equal to the first term times 1 minus this common ratio, which is negative 1/3, and it's raised to the 5th power, divided by 1 minus the common ratio. So again, we need to follow order of operations here. Maybe I'll just work straight down. So now I'm going to get 12 times 1 minus, and then this will give me negative 1 over 243. Do not simplify that negative negative. Do the exponent first. And then I'll go ahead and add the bottom. This can become a plus sign, so this becomes, I can change my whole number 1 into 3 over 3 plus 1/3. So now 12 times 1 plus 1 over 243 over 4/3. I need to add what's in the parentheses. I can change my whole number 1. I'm going to change this to 243 over 243. So in the parentheses, I get 12 times 244 over 243 over 4/3. I can simplify. I can divide both of these by 3. So 3 goes into 12 4 times. 3 goes into 243 81 times. This will simplify, and it will become 976 over 81 divided by 4/3. I'm going to do a keep flip change. 976 over 81 times 3 over 4. I can simplify diagonally. 3 goes into 81 27 times. 4 will go into 976 244 times. Simplified fraction, 244 over 27. And that is the sum of that finite series or sequence. Now we're going to see the summation notation, or the sigma. So let's try number 8. So if you recall, the formula was this: n I equals 1, and it was raised to the a sub 1 and then r I minus 1 power. So for this one, normally this number that's right here is the first term, but it's only the first term when your summation notation looks like this. Notice the power on my common ratio is I. It's not I minus 1. So in order to find the first term, I need to go ahead and plug in to get the first term. So my common ratio is the 3. That's my R. So R equals 3. But my first term, I'm going to plug in a 1 for the I. So 2 times 3 to the first. 2 times 3 to the first is 6. I need these two numbers for my formula. So again, my formula is S, and this is going to be S sub 6, because that's my n value here. And I'm going to be doing a sub 1, which is 6. Again, different 6's here. So let's see, this 6, let me do it in green. This 6 is the n. This 6 that I wrote in red here is the first term. So then I'm going to multiply 1 minus the common ratio raised to the n power, which is this green 6, that's not green, divided by 1 minus 3. So let's follow order of operations. S sub 6, 6 times 1, 3 to the 6th power is 729. I'm going to subtract S sub 6, negative 728. And now you can multiply and divide. If you want to simplify, you can, but you don't have to. This will end up being negative 4,368 divided by negative 2, and the sum is 2,184. So the sum of the first 6 terms of this geometric sequence are 2,184. Let's try the infinite series. So this is the formula when your series goes to infinity. So again, a sub 1 times r, common ratio to the I power. Notice this time the I at the bottom equals 0. For this, your r value has to be a fraction. It's got to be a number in between negative 1 and positive 1. And then once all this scenario sets up, then it's the first term divided by 1 minus r. Now, let's say the sigma notation had I equals 1. Then over here, this would be a sub 1, and then it would be I minus 1. So these two are the same thing. What's changing here is the I value at the bottom. Because your goal here is to make that exponent on the common ratio for the first term to be a 0. So let's try an example. So they're giving us the sequence, and they want us to find the sum of this infinite sequence. So the first thing I need to do is find the common ratio. So in order to do that, I'm going to take 10 divided by 100, which simplifies to 1/10. If you would have taken just these two, it would have gone right to its simplified form. So, okay, so the common ratio here is 1/10. Remember, the formula is the sum to infinity, first term divided by 1 minus r. My first term is 100. My r value is 1/10. I need to subtract 1 minus 1/10. I could change this 1 to 10 over 10. So my denominator now becomes 9/10. I'm dividing 100 divided by 9/10. Keep flip, change it. And my final sum is 1,000 over 9. Again, leave it in fraction form. Let's try another one. We need to find the common ratio, so I need to divide. I'm going to be doing 2/3. And again, you could do 1/3 divided by 2/3, but I'm just going to take the first two. 2/3 divided by 4/3. I'm going to keep flip, change it. I can simplify, become ones, and this becomes a half. So my common ratio is 1/2. And now I can plug it into the formula. S sub infinity, or S to infinity, My first term is 4/3. 1 minus the common ratio, which is 1/2. 1 minus 1/2 is 1/2. And now I divide. 4/3 divided by 1/2. Keep flip change. And I get 8/3. All right, 2 more examples. We'll try to get through it, and then that way tomorrow, your entire class, you can work on your homework assignment. All right, let's try 11. We'll see if we can get through it. If not, I'll finish it tomorrow. This one also has a typo. Add a negative sign to the 1/4. Okay, so again, this one is set up appropriately. Remember, the formula originally was the summation notation had a sub 1 and then r to the I power infinity, and it had I equals 0. Remember, when it's I equals 1, they're going to add in the -1 here. So my r value is the 1/4, the negative 1/4. So that's my r. And again, the formula, S sub 1 infinity equals A sub 1 over 1 minus R. My first term, I have to plug in and calculate it. So to get my first term, actually, since it is of the correct form, it's sitting right here. It's the 5. But if you weren't sure, take this 1, plug it in for I. So if I do that, I get 5 times negative 1/4 to the 1 minus 1. 1 minus 1 is 0. Anything to the 0 power is 1. And you can see how the first term is 5. So if this summation, this sigma, has all the correct setup, you don't need to do this because your first term is sitting right here in front of the r. But if it's not, then you actually have to do it, which we're going to have to do on the next one. We're going to have to manipulate the next one. So here we're going to take the first term, which is 5, and we're going to divide it by 1 minus negative 1/4, which is going to turn into 1 plus 1/4. And again, I could change the whole number 1 into a 4/4. So then it's going to be 5 divided by 5/4, which gives me 5 divided by 5/4. Keep flip change it.
What makes r negative 1/4?
I'm sorry?
What makes r negative 1/4?
You need to change, you need to add in a negative sign. See how I put it in red? It's a typo. So it's in the correct format, so what was in that parentheses is your r value. Keep flip change this, simplify, and the sum is 4. And for the last example, what we're going to do here is we need to fix this because notice this 10 is raised to a negative power. So let's go ahead and modify this a little bit. Let's go ahead and change this to summation, put in infinity, I equals 1. And I'm going to break this apart and make it negative 1 times I. And then what we can do is remember any number raised to a negative exponent is going to become a fraction. So this is really going to become 1/10 to the I power. So now we can go ahead and figure out what we've got going on here. So the base of the I is going to be my R value. So my R is equal to 1/10. To find my first term, I'm going to go ahead and plug in the 1 here. So 1/10 raised to the first power and my first term is 1/10. So again, notice again we got some duplicates here. My first term is 1/10, and so is my common ratio. So let me go ahead and just put it into the formula. Again, the formula is S sub infinity. First term divided by 1 minus R. So again, my first term is this 1/10. That's in blue. Divided by 1 minus, and again, my common ratio is also 1/10. So again, I need to subtract here. Let's change this whole number 1 into 10 over 10. So then this is now going to become 1/10 divided by 9/10. And again, I'll do keep flip change. So let's go ahead and keep flip change it. So 1/10 divided by 9 over 10. So 1/10, flip it upside down. So flip this upside down. This will simplify diagonally. And then my final sum is 1/9. So that is it for the notes on section 11.3, the last section of the year.